We're going to solve these systems, and we're going to solve these systems for the two unknown variables. So we're going to take a look at A first. So in A, we have, let's just get A here. In A, we have A over 2 plus B over 3 equals 1. Now, I want to get rid of those fractions. Although, we can do this with fractions, I'm going to get rid of those fractions. The divide by 2 with a times by 2, a divide by 3 with a times by 3. So when I multiply this out, the 2's cancel, so I still have a times 3 and a times A. When I multiply the next out, I have the 3's cancel, but the 2, I still have a times 2 and I still have a times B. When I multiply the 1, and again, make sure that you're multiplying all the terms in the equation, so balancing the equation, I end up with 1 times 2 times 3, so I get 6 over here. So that's my equation 1 to start. This is my equation 1 at this point. These are the same equations, one is just in whole number coefficient terms. So then I move on to the second equation. It's A divided by 4 minus 2B divided by 3, and that's equal to negative 1. So the same thing's going to happen here. I want to just deal with whole numbers, so I'm going to get rid of the divide by 4 and divide by 3. With the times 4 times 3, I got to make sure I distribute to all terms. Okay, so just make sure I'm doing that. So when I distribute to the first one, the times 4 divide 4 cancel out, so I'm still left with a times 3 times A. The times 3 divide 3 cancels out, so I still have a times 4 and a times 2B. So that's going to be negative 8B. And here again, don't forget to multiply all the parts. I have to keep the equation balanced. So I get negative 1 times 4 times 3 gives me negative 12. I'm going to simplify that to 3A minus 8B equals negative 12. And there's my equation 2. Now, since the coefficients of A match already, I'm just going to take equation 2 and I'm going to subtract it from equation 1. Now, when we're subtracting, we have to be careful of the signs, because in this case here, it's easy to remember that the A's cancel out. Okay, I've got a zero pair going on here, so these are going to cancel out. But I have a 2B minus a negative 8B. So it's minus a negative, so it's really plus. So I'm going to end up with plus 10B. Now I don't really need the plus in there, so I'm just going to erase that. I don't want it to be confused for an addition. Okay, so on the right-hand side, we have to watch out for the double negative. So it's going to be 6 minus negative 12. So it's going to be positive 18. So when I solve for B, I get 1.8, divide both sides by 10. This is equivalent to 9 over 5 as a fraction. So once I've solved for B, I can solve for A by substituting into either equation 1 or equation 2. It looks like equation 2 is easy enough, so I'm going to substitute for B here. So instead of using B, I'm going to use what I solved for here, which is 1.8. Okay, so I'm going to replace this B with 1.8, and just so that we can see where it came from, this is our answer. We're replacing it for B, so that's why that 1.8 ends up there. I'm going to multiply this all out. So I end up with 3A minus 1.8 times 8 is going to give me 14.4. That's going to equal negative 12. I'm going to add 14.4 to both sides, and that's going to give me positive 2.4. Okay, so now I can solve for A by dividing. 2.4 divided by 3 is going to give me 0.8. As a fraction, that's equal to 4/5. Okay, so there's my solution. So if I were to graph this, my intersection would be at A equals 0.8, B equals 1.8, or 4/5 and 9/5.